This is the last lesson in this unit. I am not going to teach this whole lesson. There's a tremendous amount of review in it. So what I'm going to do is I'm going to do part of it, and then I'm going to let you go through the rest of the notes yourselves. I have posted the filled-in notes already to your classroom page, and there is no point in me wasting your time. So what I'm going to do is I'll do the parts that I feel like are necessary, and then I want you to pull up the filled-in notes, go through the rest of it, okay, yourselves, and then I'll just answer questions. So you will fill in the rest of the notes yourselves by looking at a lot of it. You're going to know. You're going, well, I already know how to do this. And then you'll have the filled-in notes to check against to make sure you're okay. But otherwise, you're going to get bored because I'm going to be too repetitive. Graphs of polynomial functions. Now you notice analytical, graphical, and numerical approaches. Some of this stuff you did in Algebra 2, particularly on the front page. He talks about a leading coefficient test. I had never heard of a leading coefficient test, but all it means is stuff you already know. If a function's degree is even, meaning the biggest exponent's even, do you know what the ends do? They go the same way. Did you know that? I thought you did. So if your degree is even and the leading coefficient is positive, what way do the ends go? Both up. If your leading coefficient is negative and your degree is even, both down. If the degree is odd, what do the ends do? Opposite ways. If, let me go down here. Let me just make some extra room. Let me make some extra room here. I give you a function, degree is odd, leading coefficient is positive. You tell me that a degree odd means that the ends do different things. If the leading coefficient is positive, which way does each end go? Do you know that? Left, down, right, up. How do you know that? Lucky guess. Okay. I go back to something like this. X cubed. You guys know what x cubed looks like? Show me with your hand. What's x cubed look like? X cubed goes like so. X cubed goes like this, roughly. Degree is odd. Leading coefficient is positive. Rises to the right. Falls to the left. We say end behavior as x approaches infinity. What does the y value do? Approaches infinity, and we say in calculus it increases without bound. As the function approaches, as x approaches negative infinity, what does the function do? Approaches negative infinity, we say decreases without bound. So when the leading coefficient is positive, you rise to the right and you fall to the left. What about when the leading coefficient is negative? What if it had been negative x cubed? Would have been exactly the opposite of that. Yeah, exactly the opposite of that. So what this asks you to do, and I think this would be incredibly tedious, it asks you to graph every one of those, how many? 14 graphs on the calculator, and then fill in all that. I don't think you need to do that. Am I wrong? So let's just pick 2 or 3 of them. Let's pick this one. Even or odd degree? Even. Positive or negative leading coefficient? Negative. Now, forget those last two columns right now. What do the ends do? They go the same way. Which way? So both ends go down, so it's going to go something like that, right? So to the left, does this thing rise or fall? Fall. Oops. Fall. To the right, does this thing rise or fall? That's what this first page is. Let's go down and do, let's do this one, number 8. The first column said, I forgot what the first column said, even or odd degree? Odd degree, because the degree is 5. Leading coefficient, positive or negative? What does that tell me about the ends in words? What's it tell me? Opposite. Does it go this way or does it go this way? First or second? Second goes this way. So to the left, what does this function do? Rises. To the right, excuse me. And you do know these two last columns are talking about end behavior. Right? End behavior. And remember, what the end behavior means is as x approaches positive or negative infinity. That's what this means, this rising and falling to the left and to the right. Number 13. What's that one do? Let's see. Degree, even or odd? Leading coefficient? Do the ends do the same thing or different things? Same thing, which way, up or down? That's the front page. Dang, got that. Study the information collected in the table in the previous page. Well, we didn't do too much of it. What general inferences can you make about the about the end behavior based on the degree of a function? All right. Here's what we got to do. Even degree, positive leading coefficient. Even degree, negative leading coefficient. Odd and positive. Odd and negative. That's what we got to do. Even and positive. What do both ends do? They go the same way? And both up. So rises on both ends. We would say f of x approaches infinity. Even degree, negative leading coefficient. On both ends or one end? Down on both ends. So we would say f of x approaches negative infinity. Odd and positive. Same or different on the ends? Different. Odd and positive. Left is down. Left is down. And right is up. Good. Last one there. What do you think? So f of x approaches infinity. Any questions there? I didn't think so. All right, let me stop here. Let's do this first graph here. We're just going to complete the table. Now look at your picture. What are the zeros and what are the multiplicities? -3 is a zero. Do you have any other zeros? 1. What's the multiplicity of -3? Why? The graph changes concavity there. Good. What's the multiplicity of x equal 1? Because? Good. Just a nice cross. Good. Degree and type of function. What's the degree? How do you know it's quartic or degree 4? Good. The sum of the multiplicities is 4. Type of function. You said it was quartic. Determine if the leading coefficient is positive or negative and justify your conclusion. Then we'll do the other part. Do you think the leading coefficient is positive or negative? Negative. Because both ends do what? Both ends approach negative infinity. Then write a possible equation for the function. Now I want to remind you of something before you do that. A polynomial, and this is going to make your hair stand up a little bit, but I don't want you to stress about it. A times x to the n plus b times x to the n minus 1 plus c times x to the n minus 2 plus blah, 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 plus, I don't know, w times x to the 0. What's x to the 0? X to the 0 is 1, and 1 times w is w, so that's a constant, right? That leading coefficient may be 1 and it may be something else, right? Okay. If -3 is a 0 or a root, what factor did it come from? So I'm going to write f of x equals, now I want you to leave a little space here and I'll tell you why in a minute. X plus 3 quantity cubed. If 1 is a 0, what factor did it come from? X minus 1, how many times? Now you remember I told you that the leading coefficient might be 1 and it might not be 1. If we FOILed all this business out, what would our leading coefficient be as is? This would end up giving us an x cubed, and this would end up having an x, and x cubed times x is x to the 4th. The leading coefficient would be 1, because the leading coefficient of both of those x's is 1. The coefficient of both the x's is 1. You need to slide an a right in here because the leading coefficient might be something else. So, now let me show you this. If you wrote just this, is this a possible equation for the function? That is a possible equation, so I'm not going to fuss at you if you just write that. But the general form for any equation for that function, you'd have an a right there. So you could put a 2 there, you could put a 5 there, you could put a -3 there. Yeah, I am. Yeah, yeah. If this is orange, yell at me. Okay. Thank you. Because the leading coefficient does have to be negative. Thank you. In case, see, this general form, do you notice that the y values are not tick marked off? So we don't know what that maximum is right there. So this might be -2 times this stuff. It might be -3 times this stuff. That's why we'll just put an A. Are you okay there? Do we need to do any more of those graphs? That's what I thought. Next page. Now I want to look, because I was thinking about this last night. I'll tell you what, I'll be honest with you. I'm not going to do any of that page with you now. I do want you to do it yourself, but I'm not going to do any of it with you because I will be insulting your intelligence. Now, some of you might say, go ahead and insult. I'm okay with that, but yeah, right here. Go to the page where you start having graphs, and we're just going to pick one, okay? You got a couple pages. You got a bunch of graphs, don't you? Yeah. Pick one. We got F here. We got G here. We got little f, little g. Somebody pick one. H, like this one right here? All right. So what are the instructions? I don't even know what the instructions are. Completely factor each function below. Oh, that's done already. Okay. Identifying the zeros and the multiplicities. I can do that. What are the zeros? -2 with a multiplicity of 2. Let's do this. X equals -2 with a multiplicity of 2. What else we got? And x equals +2 with a multiplicity of 2. What else does it say to do? Then using the zeros and the end behavior, sketch a graph. I can do that. I'm going to emphasize to you the word sketch. How many of you had Secret for Algebra 2? You didn't sketch anything. You were precise. We're not worried about precision anymore because we're only concerned about certain things. So we want to sketch a graph based on those zeros and their multiplicity and the end behavior. Now look at the leading coefficient. Look at what the degree would be. How many zeros do we have? We have 4. So what kind of function is this thing? Quartic. Does this quartic open how? What is not open? What do the ends do on a quartic? They do the same thing, but because the leading coefficient is negative, they both open down. So here's what I would do. I would make myself little something like this to remind myself that this thing's going to open down on both ends. Decreasing without bound on both ends. So we're going to say, all right, -2 and 2. Now, those are the only places that curve crosses the x-axis, correct? But look at the, I used a word I better be careful of. What word did I use? I used crosses. Does the curve cross the x-axis at either of those roots? No. Kisses, tangent. How are we going to draw that? They go up, and down. And there is a possible picture, and that's all I need. You hear me? That's all that's important. It is not important where this vertex is. I don't care. What I care about is, do you have the zeros in the right place? Do you have the end behavior doing right? And do you show the multiplicity correctly? With me? So, do you have the zeros right? Do you have the multiplicity right? And showing that on your graph, and do you have the end behavior right? That's all I care about. Let's do one more of the graphs, and then I think I will be turning you loose. Let's pick one more. The last one. Okay, last one. All right. What are the zeros? Which way is this? Are we talking about this last one or a different last one? This one? Okay, so we're doing this one. Okay, right here. So x equals what? Multiplicity of 3/2, multiplicity of, and multiplicity of. What's the degree of this function? 4. What's a 4 called? Quartic. So now we've got a quartic function. Lead coefficient, positive or negative? Try again. Why? Because I got a negative 2x sitting right there. This really should be negative 2x plus 3. So you got a negative leading coefficient. Quartic, negative leading coefficient. What's it going to do on the ends? Both or just one? Both. So we're going this way on both. Negative 3, 1.5, and 3. Multiplicity of 1, multiplicity of 1, multiplicity of 2. At x equal negative 3, do we cross or kiss? We cross. At 3/2, cross. At 3, kiss. So let's see, can we do that? Does that work? Don't make any pointy places. So what do I care about? Have you got the end behavior right? Have you got the zeros in the right places? And do you show the multiplicities? Cross, cross, kiss. Okay. What's next in your notes? Your notes and my notes are just a smidge different. Is that it? Well, okay. Would you believe I'm done with that? Is there any of that we need to talk about further? I didn't think so.